Hey guys, welcome to another episode of RoboPapers. Super happy today to have Pim and Adam joining us. So Pim and Adam are from the team at General Intuition. They've just raised a pretty decent round, basically doing world model using game data. And I think as a start, we'll start off with a paper called Diamond, which is Diffusion for World Modeling, Visual Details Matter in Atari, of which Adam is one of the co-authors. So maybe as a start, if both of you can share a little bit about yourself before we dive into the paper, and then we can talk about General Intuition a bit more. Maybe
Sure.
Pim, you can go first.
I'm Pim. Started my career reverse engineering Runescape. So my background is sort of low-level game/infrastructure engineering. Built the largest private server on Runescape, then worked at Doctors Without Borders for a few years, working on a sort of novel data generation for creating maps from satellite data. And then started Metal, which became the largest company for recording video games, which is sort of the joining with the group that wrote Diamond. We realized we could scale this area of research up by multiple orders of magnitude. And that's where I met Adam.
Yep, and I'm Adam. Just finished my PhD in reinforcement learning and world models. Before that, had kind of started in physics and then got excited about machine learning, gone more into that, and had been working as one of the main projects of the PhD on Diamond, which was a project that aimed to combine diffusion with world modeling and then go all the way to training a reinforcement learning agent inside that world model. And then just as I was finishing the PhD along with Elwar and Vincent, who I worked on the project with, Pim reached out to us, told us about a massive gaming data set that he had access to that was kind of the stuff of our dreams in the PhD. So we took the offer to join as a team and have been working at General Intuition for the last 6 months now.
Yeah. The whole Diamond team are co-founders of General Intuition. Eloa, Adam, and Vincent, to be precise. And then, one of the things that we are not robotics researchers. We're very, very excited to be here, but we'll preface with we have a very, very heavy gaming background, and so we're excited to exchange thoughts. But we might say really stupid thing about robots, and you'll have to correct us.
Well, Chris will correct those. I'm also not a researcher, so Chris will be the adult here. But maybe Adam, it'd be awesome if you can walk us through a little bit of your work at Diamond, if you can.
Yeah, sure.
Mhm.
So yeah, the project started when I was doing an internship at Microsoft Research, and I met Elwar and then later Vincent, and they had both been working on world models in their PhD, had worked on Iris and then Delta Iris, which were both kind of transformer-based approaches to world modeling. And during that internship, we'd kind of discussed the idea of using diffusion for world modeling. It was kind of at the time that diffusion models were becoming more of the dominant paradigm for image generation. And so started playing around with investigating the application of that to world modeling. And it ended up becoming Diamond. So the kind of idea was the standard kind of model-based reinforcement learning setup on Atari 100K. So in the kind of sample efficient RL regime, can you learn a world model from the data that then allows you to do reinforcement learning, which is inefficient, kind of in the world model to get better performance? And we found that we were able to do that on the Atari 100K benchmark, and kind of looking into it, and we do so in the paper, we find that diffusion's better able to model the visual details in some of the games, which are often important for rewards, and so leads to better performance of the reinforcement learning agent. And then we later realized that actually the power of the diffusion model in the world model was much beyond what you can see in the kind of Atari games, and extended it to the CSGO data set that you can see below, and could have a kind of full 3D world model, controllable with actions and things like that, which was then what led us to Pim. And we did that world model that you can see on the screen there with just 95 hours of training data. We had 87 for training and held out set. And now we have many thousands of hours of gaming data that we can use across CS2 and other games to kind of scale this research up, which is really exciting.
So the data so this 80 something hours that you begin with, so these are basically video capture from the gameplay as well as the so-called action labels from the gamers, right? Am I right?
Yep, that's right.
Okay.
So it was kind of keyboard and mouse action space for this one, alongside the video frames.
I see.
And so you can actually play this, like just fully play a match of Counter-Strike and this.
Yeah.
Yeah, there's a video of Silva playing it down here, and believe this is in real time as well.
Yeah, so it runs on a single 3090. I think it's like roughly 10 hertz.
Interesting. So this is an action steerable world model where, once you churn out the world model, the human just put in some inputs and then the world model will just dream out, okay, this should be what happened based on the action that's coming in.
Yeah, so it's a standard diffusion model, conditioned on both the actions of the player and the previous frames. So it has quite a short context window, but for most situations in the game, you can see it allows for kind of consistent navigation around the map.
Did you have to do anything to get it to run that quickly? Just 10 hertz on a normal desktop seems like these are really high resolution images, right?
Yeah, so I suppose there was kind of two main tricks to get it to run fast, because also we needed it to run fast even on Atari for the reinforcement learning pipeline. We had pretty kind of limited compute, so the faster we could get it to run, the faster we could do the experiments and train the agents as well. So the first trick was kind of on the Atari side, was just trying to get down the number of denoising steps as much as possible. Back in 2023 that we were starting to do the work. So the dominant paradigms and DDPM and things were still using around 1,000 steps for denoising. We used the EDM paradigm. So by kind of having these like normalization wrappers, we were able to get down the number of denoising steps much lower. It worked with one, but we decided to use 3 in the paper. So it's much more similar to the kind of current flow matching models that are used in robotics today in terms of how it was working. And so that allowed it to be much faster than it was initially. And then for CSGO, as you say, the resolutions were much higher. So in order to scale it up for that, we had a kind of 2-stage pipeline where firstly we were downsampling, doing the diffusion model in pixel space, but at lower resolution, and then upsampling with a second diffusion model.
And typically, how many frames ahead would the diffusion model basically generate?
So this was just one single frame at a time. So the stability of the model requires that you're able to model that frame quite accurately so that you don't get drift over time. There was a couple of tricks that we had in there to improve the stability, but it is just single frame prediction. Unlike, again, the flow matching models today that are predicting kind of multiple steps at a time with chunks.
I see. So basically just the next frame based on the latest action label. I see. So
and some history, right? So like it takes a few frames in, I guess.
Yeah, exactly. It's conditioned on previous frames.
And if you run fast enough, makes sense.
Yeah. So the actions are going at roughly how many hertz?
So I think for this one, we were using around 10 hertz, if I remember rightly.
I see. And so literally you're talking about maybe a few of the recent frames, and I suppose the video is also maybe 10 FPS or something like that, is it?
Yeah. I mean,
I see.
Here it's so I think for the reinforcement learning pipeline we would run it as fast as possible as soon as the next frame is generated.
Mm.
And I think similarly for CSGO, it was just scaling up the model and balancing the quality versus the speed which it ran.
Interesting. Are you surprised that, I mean, it sounds like just with 80 something hours you are already able to learn a world model that can be action conditioned and kind of look like CSGO. I suppose it doesn't have all this like temporal or like spatial memory yet, but it looks possible.
Yeah,
Are you surprised that 80 hours is enough to get you something that
for sure. I mean, to be able to kind of consistently navigate the map was definitely something that surprised us. You can kind of do full circles of the map. It's not completely stable. So actually at one point we tried to gamify it a bit by having a kind of frame counter at the top, and found that like basically made it a challenge to see if you could get to 1,000 time steps without it drifting. And it was kind of a reversal of it's not the model that's bad, it's you that's bad if you go out of distribution. Because if you're playing like the pro players that were used to collect the data, then you would stay in distribution. If you did kind of strange things or quick maneuvers that were out of distribution, then it would drift. But honestly, yeah, we were pretty amazed that you could get a full like navigation of the map. And see that it was stable. And you can also see that like the kind of, we have like a heat map of where the data is collected, and you can see when you play the world model that the areas with more data are generally more stable and it's harder to go out of distribution. Other corners of the map where there's less data, it's easier. And so we knew that like the main kind of way to improve this would be to have more data. And that's why it's super exciting now to basically be in the kind of infinite data regime for this sort of research and be able to focus on the modeling problems that still exist even when you have infinite data.
Yeah, I think a few things that are interesting to mention here is so CSGO is a pretty tiny map. So
yeah, I was gonna.
Consistency very much and stability very much depends on the actual size of the environment. And so also the other thing is the amount of agents in the environment that are interacting with each other. So to navigate the map from the perspective of a single agent not really interacting with other agents, those are the two sort of major variables which all have, likely require exponentially sort of more data. So I think, that's why CSGO was also a very, very good place to start an experiment.
Yeah, exactly. So we were just looking at the Dust 2 map there.
Yeah.
Whereas, now kind of our current research is more about like how can we capture lots of different games, and kind of cram all of that knowledge of different environments and worlds into a single model. And then also, as Pim said, we found that the model kind of completely ignored other players because, you go around a corner, the most likely outcome is that there's no one there, or even if you kind of see someone, because it can't predict the movements of that player, it just makes the player kind of disappear pretty quickly. And now, we kind of start to explore like how models can handle stochastic things when you have a lot more data.
We're also pretty interested in how compositional the generalization is. So if you need like less, like how much data you need per new game to model that environment with these dynamics, as opposed to, if you have lots of data on a single game, and how each of those interactions and renderings essentially transfer.
Yeah, I guess that was one of the next things I was going to ask is like, do you see a lot of transfer between the games? Like you have all these Atari games, I guess.
We do. Yeah, we internally have already proven a lot of this work, and we're currently very much skilling it up.
Yeah, gosh, I have so many questions. Okay, but maybe just step back a little bit. I just wanted to have mental image. So the 80 something hours that this original CSGO data set that it started with, is it only from one single map? It's from one single map. Okay, and so and because the CSGO map typically is not that large. So if you play 80 hours, it probably would have seen nearly every part of that map. and so therefore it's relatively easy. Okay, and then but it just doesn't imagine the other opponents, because most of the time you just see walls. You don't see. I see. Interesting.
Yeah, and I think that's typically a function of research, right? They just didn't have access to a lot of data. So one of the things that we're excited about right now is maybe partnering with universities, make some of these data sets available for education. And so, yeah, I think the big motivation for us as a team is to also educate lots of people to be able to do this type of work, but at a much larger scale.
So I guess okay, I have so many questions, but maybe let's start with this one first, because you how do you think these world models can be used alongside basically traditional game engines, which is very deterministic, right? A world model, I guess it's generative. Maybe hallucination is one of its key features. So how do you think these two will be used together?
Yeah, it's a really good question that I think we all thought a lot about, and still, I think not completely clear. I mean, as you say, if you train this on an infinite amount of data and you manage to get everything to be perfect, it would just be a replica of the game engine. But I think what gets interesting is when you allow some of the hallucinations, as you call them, or the creativity, especially as you start to blend maybe different environments, different worlds or games, that sort of thing, and also incorporate things from video generation like text prompting and those sorts of aspects as well. That's when you can get some of the creative aspects to work well.
Yeah, I spend most of my time in sort of deterministic game engines. So a key part of game design is sort of this having to respond to non-deterministic sequences. So like, let's say in Clash Royale, for instance, you have the fact that you get a random deck, a random sort of card shuffle, right? And so this sort of element of stochasticity is like a key component of great games. And so I think my personal opinion is first we'll see rendering, like heavy rendering modules essentially get replaced with maybe like faster neural rings. And then long term, I think we just see, I think it starts with LLMs, but I think we just start seeing like more of these non-deterministic, like generative models be included in different aspects of game design. So my personal opinion is that like in the next few years, we don't see the traditional engine get replaced, but we sort of see modules of the engine get more efficient. And over a very, very long horizon, right? Like I do believe that fundamentally these models are a very general architecture to deliver frames. So they're essentially, compressing representations of space and time into a compression method of the action, right? And so, it's a bit of a generalization, but I think the games industry very much struggles with this problem of delivering experiences. And so I think a lot of the game engine, therefore, where you currently have to download like massive, like multi-gigabyte files, does just end up turning into bloat, right? And so I think that we'll first see these hackers. I think in the long term, I think we'll first see sort of world model native games as like an adjacent genre as opposed to replacing the traditional engine. And then very long term, I think those just end up becoming sort of the new genre of entertainment. But I don't think that this is a replacement. I think it's just sort of a progression that the engines are very much going to be involved in as opposed to in opposition. Because if you look at, for instance, competitive games, right, the determinism is a key portion of the experience, right? If you're playing competitive Rocket League, for instance, and your opponent sees a different, like slightly different rendering of an object, then that's an unfair advantage, and you don't want that, right? So I think determinism is a really, really key feature. But at the same time, there's lots of, I think, efficiency gains to be had from these world modeling techniques.
So maybe this is a good segue to talk about like you guys' vision for general intuition. So it sounds like what you guys are thinking about is really within the game industry, how to basically light the fire there and do something, allow the game designer to do something cool. Is that what you're thinking? Yeah.
So our focus is on, so we realize that we sort of have so much of this data represented that we can immediately start focusing on agents. And so while we work on world models as part of the research, really the focus for us is at the moment an agent that can play any video game. And so So as we mentioned, we just raised the Code's largest seed bet since OpenAI. And the reason for that is because we obviously have a very, very large data set that is really, really unique. And, in Adam and his co-authors, an incredible founding team. And so, our focus is building general agents for environments that require deep spatial temporal reasoning. So focusing on, right, one way to think about it is, as humans, sort of our intelligence first developed in these three-dimensional spaces, and we later, as sort of a subset of that, introduced text in order to communicate. And so one way to look at text is a sort of compression method of reality, right? And of spatial temporal information, which then obviously allowed for many sciences to sort of flourish on top. And I think that's beautiful, but fundamentally, a lot of these problems where LLMs are failing is because they largely rely on text for their generalization. And so what we're trying to build is essentially this spatio-temporal backbone in a foundation model that we can then leverage, right, text modalities and others in order to produce frontier models. Very, very similarly to sort of Anthropic hard focus on code, we want to focus on general agents for spatial-temporally heavy workloads.
Yeah, so it's like now instead of just human gamers who can play against me, you have much better maybe AI players in these games taking me on.
Yeah.
Okay.
Yeah, an
all my
initial
data
use case is very much very, very, very good bots.
Got it. And could you share? I mean, it seems to me that your secret weapon is the data set that you've gathered. Maybe you can talk a little bit about your journey, Metal.
Yeah.
Like, who are these players? Why are they giving you the data? Unknowing. How does this?
Yeah, I don't know.
I read about.
I would
yeah.
classify Adam as a pretty good secret weapon as well, to be honest.
Yeah. Oh yeah, for sure, for sure. I mean, data without researcher is like nothing for sure. Yeah.
Yeah, the data set is massive. It's so Metal gets roughly 1 billion video uploads per year with action labels, right? And so as a result, that's roughly a YouTube scale data set, except there's two problems with the YouTube data set. One, it doesn't have action labels, and so especially for training agents, that's a bit more difficult. And secondly, it's not fully in perception, right? So you have to rely on pose estimation. And also, one of the beauties of video games is that you're essentially, right, the information that you're making decision based off is completely limited to screen. So you're basically forced to simulate these optical dynamics with your hands, which sort of force these spatial temporal consistency of the information and the decisions that you make. And so we sort of have this strong belief that games are a very, very good representation of spatial temporal reasoning that's much harder to derive from even starting with real world data. So we really want to go deep on this general agent that's capable of spatial temporal reasoning, and then branch out from there in terms of the research.
Yeah, could you comment what is Metal about? Like, why are people uploading this 1 billion action labels?
So
for non-gamers out listening.
Yeah, so look at it this way. I'm sure you've all watched streams before, and people upload these videos with their game controllers overlaid on the screen, right? So when you're playing video games, you're traditionally doing one of sort of three things in the background. You're on voice, talking to your friends on Discord, probably. You're live streaming, and then you're probably streaming to either YouTube or Twitch, or you're just recording for either your followers or your small groups of friends, more like private initially, but then you get, some people amass large amount of followers, and then you start posting clips to Metal. So the sort of public graph of and live streaming graph is sort of the YouTube and the Twitch graph. And then we are more like the Instagram or sort of Snapchat equivalent. So people have profiles, they post there, but they tend to have maybe between 5 and 10 followers. Some users grow to hundreds and even tens of thousands of followers. But it's really about, right, these native gamer interactions of already having these controller overlays and things like that as part of the feature set. People also love to, for instance, navigate clips by the actions that they take, right? So and also the events that happen as they progress throughout the clips. So we just have this very natural flywheel that's very ingrained with what people already do on Metal that gives us access to just this amount of data. And so the sort of it's really one way to look at it is it's the episodic memory of humanity and simulation across billions and billions of hours of playtime. right? It's public at this point. Metal has over 10 million users, right? And so you can sort of think through, do the math there. People use that 10 million monthly active users. So the amount of uploads is massive, and so we really can sort of take this YouTube skill bet that no other company is currently capable of taking.
Yeah.
So Metal was a existing company that General Intuition is built on.
Yeah. So you can sort of think of it as like XAI and X, or Twitter before it was X. So we have both the core company and the research as part of the same group.
Yeah, I'm curious, at the early stage, right? It seems to me if it's purely a social thing, you probably just need the video. Like, why did you even collect action labels? Like, was it a feature, or do you just have this foresight that the action labels will be useful to form general intuition down the road? Like,
no, it's quite funny. I tell people it was worse than luck, because I was actually working with Dr. Sub Borders, and as part of that, I got to spend some time at Google Crisis Response, which happens to be in sort of the same building as Google DeepMind, and I think it was 2016 or 2017 at the time. And so, I had many conversations with people on lunch about this type of research, and I started Metal a few years later and did not even put the dots together. So I tell people it's worse than luck, because I had some prior knowledge, and even with that, I wasn't able to connect the dots. And so it wasn't really until really the Genie paper and the Sima paper where it became super obvious to us that this is sort of the bet that we should be exploring. But we already had features, for instance, around overlays, where people could, put their controller up or their steering wheel up on the clip as a part of the content. And then also in the timeline of navigating the clips, for instance, like gamers love to see like the specific labels of that. And maybe just worth noting, just for clarity, that like these feature sets, and participating in this, you can opt out of it at any time. It's just in the settings. We're also very transparent about the fact that we do this. That's why we did the announcement, to sort of make it very, very obvious and open about what we do. And also the sort of every single consideration that we've taken around designing these systems, we've published on the blog in case anybody wants to look into how it works.
Yeah, this is it is super cool. I mean, so you mentioned, so one problem with YouTube is video without action labels, right? And clearly you guys have the action labels. But I think there are a lot of work now trying to infer action labels from video. So I think some of the earlier work from Jeff Kloon, I think Minecraft or something like that, where they just purely just from Twitch or something like that. So obviously no action labels. How do you guys think about those? Like, is it just because you guys have the so-called first dip into and those are the cleanest action labels since you record at source versus something to infer by something like IDM and all that?
I think that's definitely an interesting direction to kind of label videos, and something that obviously we look into as part of our research. But having kind of millisecond perfect action labels, the kind of the ground truth, I think gives a lot of benefits in itself. And not only that, but we also get a much greater diversity of actions as well as a result. So, if you think that there's all different kinds of games, and on Metal we have the kind of a lot of unique games as well that are a lot less popular, that simulate certain things and have very specific niche actions, and kind of all of that is captured as well. So it's a much richer set of actions in that ground truth data set than you could get just from kind of trying to label general videos.
Yeah, it's worth noting that those types of models tend to have limitations in terms of the actions that they were trained on as well. So for us, it's about really going very broad and almost taking we like to describe it essentially taking the LLM bet, but for action prediction. And so our research is very much because we have such a broad action space that we have ground truth labeled, we can take these types of sort of bets that were only really possible in early LLM days on web skill data.
So the action space here is it's mouse, keyboards, just everything you capture, right?
We don't ever capture sort of the actual keys. So we convert everything over to actions before we store it anywhere.
So it would be like jump.
yeah.
It would be like
exactly.
Okay,
Yeah,
like
yeah.
look left and then jump. I guess. Okay. Yeah.
Oh, so if it's a Street Fighter like combo move, like the fella press A right, and then so is the action. Oh, I see.
Yeah.
Interesting.
Like light,
I guess
heavy or something. Yeah. Right.
Sorry. Yeah.
It'd be like light attack, heavy or something, right? Like that.
Yeah.
Yeah. Not A. Right. Okay. Yeah.
Oh, okay. Yeah.
So
I guess
like if you wanted to do this in the real world, you would say you could like wear a set of AR glasses and have it tell you to jump. I don't know. Said climb the stairs.
Yeah, I'm trying to like tie this back to I guess obviously this podcast is about robotics, and probably in the embodied AI space, the entity with the largest or maybe similar data is maybe Tesla. I'm guessing they have videos, probably what the driver observed, as well as they must be recording what the driver is doing. So action labels. Like, is that the parallel you guys think about it? Or maybe you guys don't think about robotics at all?
Yeah, we take a lot of inspiration from how Tesla developed FSD, which was, very, very similar paradigm. In fact, there's even literally a clipping button on the Tesla steering wheel, right? So the parallels are very close. The beauty of our approach is that when you're playing video games, you're essentially transferring your perception to whatever embodiment you're playing at when you're playing the game, which means we don't just have transfer sort of between the action spaces, but also between the embodiments, right? And so where Tesla has like a very narrowly focused data set on driving, like our bet is not that we can serve self-driving car customers with better models than Tesla. It's that starting the next self-driving car company is going to require 99% less data, right? And so for us, that like really the bet is on these general models that are very, very capable of transferring to new environments with very, very little data, assuming that the action space and the embodiment is already represented in the data.
Yeah, it's also just a much richer action space than Tesla, right? Because Tesla's 2 DOF, right?
Yeah.
Maybe.
Yeah.
Right. How do you actually handle that? So you have if you have so since it's not mouse and keyboard is like a pretty fixed input size, but now you have the infinite length of all the possible actions that a video game character could perform. Is that fair? Okay.
Yeah, and they're not all discrete actions, right? We also have continuous ones, for example. So, the diversity is really rich, and so, you don't want to say anything else on that?
Yeah, just that it's a really interesting research area as well. Is a lot of the previous work on the space is restricted to navigation actions only, like Pim mentioned, Ema and Genie. But we really want to look at how do we extend that to kind of much richer action spaces, and how do we capture the meanings of those actions and transfer that between games and environments.
So about how many, you said 10 million active users. Sorry. How many games roughly is that?
It's a lot. It's
a lot. Okay.
Many, many, many thousands, if not tens of thousands of environments.
Yeah. I think for most of the guys who listen to this podcast, they're actually researchers, I think, doing the robotics. The number one complaint everyone have about robotics is there's no data. And usually they means that there's no data with action labels. Usually that's what it. So so I think that's why this is so interesting. Is like, Pim and you guys show up with okay, actually there's a lot of gaming data. But I guess if I'm a robotist, and maybe Chris, you should add on to this because you are the actual researcher.
You're a roboticist, Michael.
Okay, cool. I talked to enough to
now.
Yeah. So I imagine there may be some not criticism. Okay, so just questions, right? So it could be a lot of these game engines, they are optimized for the aesthetics, right? They're not no fidelity. In fact, there are crazy things that you obviously cannot do. You can't fly around. Like a Dragon Ball game, you can fly around the world, right? It's physically impossible. What would you say to that? To robotics?
Yeah, so I think there's a few areas to touch on here. One, there's maybe the history of gaming related research and what their limitations were. Second, how we are designing. So maybe let's start with those two. So first, our focus is not just on robots, right? So if you want to deploy your agents in a game, you actually wanted to understand those actions deeply that are maybe more unrealistic. And so our job is not necessarily to deliver the complete end-to-end solution for your robot, but it's really that to move most of the hassle that you currently have to do for pre-training, but move it to post-training, right? So our bet is that we can sort of build such a good like spatial-temporal foundation model that has many of these actions represented that you just need less data to deliver whatever you want to build, right? And so, and the other thing is, we do also just have access to these types of egocentric data collection method that other labs would have access to. The bet for us is that we would just need a lot less of it because we've had such a sort of a large understanding of this very large action space. And so, so that's on our bet. And so we actually want to build models that you can deploy both in simulation and in physical environments. And so that's one. Second, I think there's a few things on games and game engines in particular. So game engines are getting sort of more accurate every year in terms of physics, right? This is a huge part of why people start playing new types of video games. And so you can sort of think of like for instance, flight simulator is very, very popular. Train simulator. There are these. There's both a representation of these extremely accurate sort of simulators, than the less accurate ones, which is what you want. And then lastly, we are also investigating, for instance, can you actually use, for instance, text chain of thought in order to sort of guide, and then use the understanding of these action space in order to carry out the action. So I think for us, the thinking is not that we think that the game's foundational data is the end solution. We just think of it as like a very, very good head start that maybe gets us to where we thought we could be as an industry 5 years from now, maybe in the next 12 to 18 months.
And I think, as you said, with robotics, we're not roboticists, but we know that like in robotics, it's generally data constrained. So we're able to do the research with that kind of infinite amount of data, address some of the modeling questions, like see how things scale. And our hope is that a lot of those insights would then transfer over to robotics, where maybe the data is different for fine tuning, like Pim said, but a lot of the kind of modeling approaches and unsolved problems with getting longer context lengths and things like that, we can solve in games where you can also iterate much quicker with deployment as well, because games are much easier to kind of spin up and try things out as well.
Yeah. And I think a few things also worth noting is that a lot of the historic research done on games was related to game state, and like this sort of general approach that we're taking at this scale has really like never ever been tried before. And so I think we're very, very confident that we can sort of get to this point of making the life of every person trying to deploy into both real world systems and robots and perhaps even like our hope is that this sort of transfer that we see between environment to environment within the action spaces that we have inside the platform, maybe with enough systems, we can start looking into can we go from this general action space to like more like torque to a motor or something like that with another approach, right? And so I think we're very, very, very interested in hiring people that have this type of expertise at the moment, given that this is not where our expertise is. But if there's people listening that have that sort of expertise that can do this like last mile delivery into robots and like understand these systems very deeply, we'd love to chat.
Yeah, I imagine like if you can tell some of these researchers and say, hey, you guys have a very, very good world model, and that it's basically have all this temporal spatial understanding that's going to translate very, very well, then there will be people who do more of this like online RL directly in a big world model.
Yep.
I think that's the promise with world models for robotics, I'd say, because in the real world, this is just nearly impossible to do like online RL. Like you break the robot, that's it. Like someone need to go and fix a robot.
Yeah, it's maybe worth noting that the reason why we decided to build an independent lab and not work with any of the larger frontier labs is because if you're one of those labs, you sort of have to build these world models first, and these are extremely costly to train, and they're also very, very difficult. And so our bet is that we can sort of get to a place of having this, like LLM like. Right, and I use this as like LLM as the parallel to text, right? That's the only, LLM, like the way to think about it is LLMs are obviously trained on like large scale web text data. We're sort of doing the same thing, except for action prediction, right? At sort of that skill data set. And so our bet is that we can kind of initially skip the world modeling stage to get to this first foundation model. And then in parallel, we're scaling our world modeling research, which is being led by Anthony Hu, was the lead research scientist on Gaia 1 and Gaia 2 at Wave. So for us, it's really about being able to leap the world modeling space by, hopefully 2 to 3 years, by being able to get the results that you would want after you train these agents inside world models a few years before, and in the meantime also scaling, right, the world modeling research to be able to get more environments to scale once that sort of base policy is there. And so that's our bet. Like I think a big point of feedback that we got from the raise was who in their right mind starts a frontier lab in 2025, given the capital requirements. And so for us, it was really about knowing that we could leap by this much. That gave us the confidence to do it.
Yeah, it's great to hear you guys got Anthony. I saw. Yeah. I've been keeping track of Gaia 1 and 2. Yeah, very impressive. But yeah, I guess similar thing. World model. Also with action label with videos. Yeah.
But an easier one again. With Gaia 2 still 2D, right?
Yeah, well, I
2D
guess
meaning action space.
Yeah,
no, obviously
2D
it is
action
3D,
space.
like video.
Yeah, I guess robotics have navigation on one extreme, which is just 2DOF.
Yeah.
And I don't know, my own suspicion, I don't know whether like Adam and Pim, you guys, how do you guys think about it? I'm thinking maybe it's the wrong games I'm thinking about, but it seems to me like for robotic navigation where the agent in this case is moving through a long distance in this virtual space. I think those game data will absolutely help a lot. But then there's the other side of robotic, which is actually the environment doesn't change all that much. Let's say it's a boring kitchen. There's no one else in the kitchen, but you as an agent, you have like, I don't know, like 60 DOF, between your two hands and your whole body.
Yeah.
So, but the objects themselves, some of them are deformable, and then cloth and things like
There's
that.
like kitchen simulator, cooking simulator, and all those, right?
Yeah. The bet for us is really at the moment not on these like higher DOF systems. It's really on systems that have a DOF similar to the action space and the inputs that we already see represented, right? And so for us, it's a lot more about transferring to any system that already has gaming inputs. So like, every robotic arm, for instance, does also ship with a game controller. And like we really focus on sort of predicting at the level of the controller itself, as opposed to predicting at like, the precise dynamics. And we think that, this is sort of we're not suggesting that this is the only way to solve it. We just think that it's going to get us really, really far. And then allow us, right, with also having access to the sort of last mile delivery type of data, to go there. And I think also for us, like, if we, like, fundamentally intelligence is the bottleneck. And so if we believe that if we unblock intelligence on this, in within this DOF, that actually we'll see supply chains and manufacturing adapt to those type of systems as opposed to going for sort of the higher DOF variations. And I think one other thing to mention, for instance, is that like very, very many times, there's a lot of the systems that you'll be operating in are fundamentally weight and energy constrained, right? So if you actually can just predict like simple discrete actions into embodiments as opposed to these very dependent continuous actions for robots, then often actually the discrete actions might just be the simpler answer. And so our bet is really that if we solve this problem fast enough, that we'll see supply chains and embodiments sort of move our direction. And hopefully simultaneously as that's happening, right, we can also scale up to higher DOF action spaces because we see the generalization and transfer apply, hopefully to both action spaces as well as environments.
And I think you already see this to some extent in robotics with like vision, language, action models, right? That you have the vision component and the language component, which are pre-trained on much larger data sets. and then you train end to end to get the kind of action component out, and this could be another component to that, which bakes in a lot more external knowledge of physics and actions and environments and things like that.
Yeah.
Cool. Yeah. I mean, one thing that I'm super curious about is whether or not you can use this kind of these huge data sets to solve the long horizon problems, because like that's something that robotics always struggles with. It's hard to get data, but it's even harder to get data that is like a 20-minute CSGO match, right? Like that's quite a lot.
Yeah.
So I know that you were saying before there was just a couple frames of history, but I assume you guys are thinking about like solving that problem.
Yeah. We have really, really long sequences as well. And like the diversity on both sequence length and skill, and is very, very high. And it makes for like a very, very great place to do research, I think, because you're really thinking about the bets you want to take as opposed to sort of how are you going to get like these very specific types of data. And the other thing that's really cool is that it's all in one general format, right? So you don't, where if you're currently a lab that might be working with type data, you're going to get different data per video game, and then you have to normalize that into like a single set, and then that's going to take a ton of time, right? For us, it's really about having that one general format that we can sort of take straight into the different models that we're building, and that's why having sort of the integrated company is so awesome. Because also as games, right, get more realistic and represent the real world better, they introduce new actions, and so we really look at it as this flywheel where games just, the spatial-temporal reasoning represented in games just gets you really, really far into transferring out to other types of embodiments as well.
Yeah, I think this is really incredible. Like, I feel that, it's so hard to get action labels. and because I mean, I feel that the internet by and large is just like a big dump of humanity's like conscious thoughts, right?
Yeah.
We can record our text and images and videos, but then the way we move in the physical world, we do it subconsciously. So unless you put a human in a robot on a car, which is in tested case, but then in your case, you put a human to drive some virtual digital beings, embodiment, and then get the action label. Like that's a very good hack, because otherwise you can't get action labels. And yeah, I think that alone is definitely. I think could be something that no one else has really tried, at least to the scale that you guys have, I think.
One thing I'm personally really interested in is, going into slightly speculative territory is, I see your nervous smile. No, but like one thing I'm interested in is, right, text models are trained in sort of what I describe as described reality. So somebody wrote like a textual description of their experience. And I'm very, very curious what happens when you train these foundation models purely in perception, and where they have sort of no separation of the two, and everything is as perceived, and then you add in things like text data. So I have a lot of these questions, like, and I'm really, really excited about, like, it's almost like you said one level up on the hierarchy stack, right? It's perceived reality, described reality, and then you get LLMs. And I think we are going to inject that sort of perceived reality foundation model, then add in text, and then everything else. Yeah. And so I am genuinely really, really curious about the type of outcomes that we'll see. And, we'll have different types of problems, but maybe just going to see very, very different types of intelligence that is fundamentally spatial-temporal that I don't think we've ever seen before. And we're excited about it. We're also excited to bring really, really smart people along the journey. So if you're interested in joining us, you know where to reach us. And
do you think?
Chris. Yeah.
Oh yeah. I mean, do you think that you'll need to do? I think it's a really interesting observation that like modern AI, like reasoning models and VLMs and everything we have is really kind of text first and built around that. Do you think you'll need to do like really fundamental like architecture stuff? Do you think like move past transformers? People have always threatened to do this for a long time. Have you guys put any thought of that, or is that?
I'd say anything's on the table, but we're not at that stage at the moment.
Yeah.
We investigating kind of like how we can solve the problems that we talked about, like increasing context, for example, and we'll see how that goes.
Yeah, I mean, to your point, like I don't know whether you guys saw this paper from DeepSeek OCR, like, it's like rethinking of text tokens, and it actually is just, I mean, everything for humans we read first, right? Like these are still pixels in, and then we think of it as, like text. So, yeah, it's interesting how this all goes. Yeah, but I think to me the biggest thing is you guys have a lot of action labels, and that's got to account for something. There's I'm sure there's a lot of. Okay, so I guess how should researchers reach out to you guys? Like, do you guys have a career page you want to hire?
Yeah, I think a few things. So careers at generalintuition.com. We read everything, and I think the two particular types of roles that we're looking for very actively right now are research engineers and research scientists. So a lot of work on the infrastructure side to deal with like this amounts of video data, right? Indexing, like sort of making it like a really, really, really enjoyable to be a researcher here. And we've done a lot of this work, but I think we could do a lot more of it. And really like getting ahead of what we could be doing with this skill. And then very, very good like research scientists, which is particularly somebody who deeply understands robotics and physical transfer at the moment. And and I think for us, if this is interesting to you, right, maybe if the timing is not right now, we'd still love to hear from you, build a relationship, and there will be a long journey, and we're excited to talk to the smartest people in the world about this. Cool. Anything from your end that you're particularly looking for?
Yeah, I think as we've said a few times, we're not roboticists, so we're super interested to hear from people that have clear robotics problems that they think that we can solve with our data. And we're open to new avenues.
Yeah, also maybe people that are really good at video transfer and different aspects of video transfer is really, really interesting to us to sort of go beyond gaming data.
And I guess maybe one last question, asking on behalf of those in academia. So, do you guys have any plan to open source some part of what you do, so that to engage the folks from academia?
Yeah. So I think the way we look at it is, we see a huge responsibility in having this type of data in two ways. One, to educate people on it, because this is the frontier, right? And so, 3 out of the 4 co-founders experienced this firsthand, where they just didn't have enough data to take the type of ambitious research bets that they wanted to take. So if you're a university that wants to work with us on getting access to some of this in order to do research, we're happy to chat with you. And then in terms of publishing, we also see a very, very huge responsibility in making sure that right. Also because, partially also because we have, right, such a great team and such a large data mode, we're actually very excited about being a lot more open about the things that we do. So I think you'll see that from us. I think in the early days, we're a very, very small team, so publishing is not necessarily the priority right now. But I think Adam is really, really a strong scientist. I think your own personal role model very much exemplifies this. And I think we are both really, really, also maybe for context, the lab is named after how DeepMind initially started to try to build an agent to play Fold It. In order to, which very much eventually led with a bunch of different approaches to AlphaFold. And Demis has a quote where he says, "Wouldn't it be amazing if you could mimic the intuition of these gamers who are, by the way, only amateur biologists?" So I think our root motivation for a lot of the team is to get to that point where you can even use it for scientific spatial-temporal workloads and create those type of breakthroughs. And that's going to require a really, really good relationship with the science community. And we intend to uphold that.
Okay, that's really awesome.
Yeah.
I think that's a great place to end the episode. Super looking forward to and I guess anyone listening interested in this data set should check with you guys.
Yeah.
Or reach out, to do some research collab.
To be clear, we do not sell data.
Yeah.
Period. But we like to we want to make sure that especially universities and students that we need to push the frontier here have access to the things that they need.
Yeah, awesome. Yeah, I am looking forward to any cool research papers, whether done directly by you guys or by your collaborators. Okay, cool. It's been a great chat. Thank you so much for making the time, guys. Yep.
Yeah, thank you guys.